Good morning, everybody. Thank you, Vian. So yeah, as Vian said, I'm Tara Southey from Tara a forward farming solution. We'll be harnessing technology for more resilient agriculture, looking at shaping the orchards of the future. So the study we're focusing on is looking at the suitability application for the South African deciduous fruit industry, focusing on climate-adapted plums. And through that, looking at the impact of climate resilience, the plant expressions in the form of geographic and seasonal approaches, looking at what's suitable for your land, understanding the environmental drivers, and looking at the economic plum production. So underpinning all this analysis is a lot of terrain and climate variables, looking at hourly, daily, and monthly temperature resolutions. So it's really going the more data-driven approach based on all the fundamental research that just presented before me. So the project's main aim was to integrate Tara data with fruit data. So I'd like to thank Pickman Vessels for all his collaboration. And then other collaborators such as Provar and Experico to combine data sets where we start looking at commercial cultivars and create suitability maps. So it's really using the know-how of what's working to identify what will work. And it's looking at identifying the plum varieties that are yielding the most market desirable fruit and to find new cultivation regions to adapt. So the first objective of the study was to build a comprehensive database. The second was to look at proof of concept. What are the driving environmental parameters driving economic performance? And the third objective was then to look at similarity maps or suitability maps. So the results of objective one was through expert panel approach and with fruit data, we sourced historic volume and export quality data. And we selected 7 cultivars: African Delight, Angelino, Fortune, Letitia, Ruby Star, Ruby Sun, and Sun Gold. And then we took 5 sites where they are producing well from an economic pack-out perspective, and 5 sites that are underperforming over a 5-year period consistently. And then we aggregated that data with environmental profile data, looking at growing your temperature profiling, terrain, and soil. And then we took that environmental profile and we looked at model feature importance per cultivar. And that's what that looks like for African Delight, Angelino, and Sun Gold. It gives you the array of environmental parameters and then a weighting in the green box. And if you look at something like humidity between 40 and 60, it had a lower ranking for African Delight, but it was a top variable for Angelino and Sun Gold. Another variable looking between temperatures between 15 and 20 degrees, higher importance for African Delight, less so for Angelino, and slightly less so for Sun Gold, which was really interesting findings. Then what we did with this data was we started to look at similarity maps. This is our first stab at it. The green areas where you have the profile is most similar to the current African Delight profile. The red areas is different. And then if we zoom into a specific area, those blue dots are sites that have constantly produced high volume and high quality African Delight, and you can see it falls into the green zones. Then looking at this for African Delight, Angelino, and Sun Gold, you can see how different the similarity maps look like. And if you zoom into an area like Pakketberg, it's not viable, doesn't look like it's a good conditions for African Delight. It's great for Angelino and not so great for Sun Gold. And as I said, this is first stab approach. It still needs a lot of experts' inputs. So if you look at the model feature importance, again, just look at where does chill units come out and heat units as 2 examples. If you look at chill units, this is a distribution of plum orchards. And we can look at the chill distribution from the bottom to the top. You're going from 350 to almost 1,000 at the top within this valley. But you've got no other data for those specific points. So it makes this kind of analysis very difficult. The same for heat units. If you look at growing degree days, you've got a lot at the bottom of the valley, and transitioning up into the valley, your chill units drops. But again, what does the production look like? What is planted there? What works? What doesn't work? So what this study has provided us with is a proof of concept that combining data sets can provide valuable insights when we start looking at future decision making in plum production specifically. There is commercial potential in this project where we can start showcasing the value of integrating multiple data sets. What works can start dictating how do we position ourselves for the future. And it's integrating the expert approach with the actual growing approach. So that's the project in a nutshell. Thank you very much. And I'd like to thank Fruidata, Pickman Vessels specifically for all your help and collaboration, and then Andre Smits for allowing us to drive him crazy, and just thank you for the opportunity. Ward Grow poem. Thank you.